and let you try this. Let's look at the solution to this inequality. Our first step is to solve the quadratic equation x squared minus 3x plus 2 equals 0. Factoring gives us x minus 2 times x minus 1 equals 0. And our solutions are x equals 2 or x equals 1. And we've graphed these numbers on our number line. Now the next step is for us to determine where our factors are positive or negative, so that we can find out where our product is positive or negative. To the left of 1, both factors will be negative, so the product is positive. Between 1 and 2, the factor x minus 2 is negative, while x minus 1 is positive, so their product is negative. And to the right of 2, both factors are positive, so the product is positive. Therefore, we know that our signs are plus when x is less than 1, negative when x is between 1 and 2, and plus when x is greater than 2. Now our inequality asks us to find the solution of the expression less than or equal to 0, so we're looking for all the values of x between 1 and 2. In interval notation then, this would be the closed interval from 1 to 2. Now, the last type of inequality we'd like to look at is a rational inequality. Now, this will require us to use some of our skills for simplifying rational expressions. Let's look at some guidelines for simplifying rational inequalities. Our first one is rewrite the inequality, if necessary, so that 0 is on one side. Make a sign graph with intervals determined by the numbers that cause either the numerator or denominator of the rational expression to equal 0, and determine the intervals of the solution set. Let's take a look at this rational inequality. 3 divided by x minus 6 is less than or equal to 2. Now remember, our first step is to have 0 on one side of the inequality, so we need to subtract 2 from both sides. Now we need to rewrite this expression so that we have one term on the left. Now to do that, remember we have to use a common denominator and write the expression as 3 minus 2 times the quantity x minus 6, all divided by x minus 6. And that, of course, is less than or equal to 0. Now we need to simplify the numerator, and in so doing, we get the expression 15 minus 2x in the numerator divided by x minus 6 in the denominator. Now our second step was to find out where the numerator was 0 or the denominator was 0. 15 minus 2x is equal to 0, or x minus 6 equals 0, when x equals 15 halves, or x is equal to 6. Now these are the two numbers that we want to put on our number line. Here they are. Now let's check the signs of each of the factors. To the left of 6, 15 minus 2x is positive, but x minus 6 is negative. Between 6 and 15 halves, both factors are positive. And to the right of 15 halves, 15 minus 2x is negative, while x minus 6 is positive. Now our inequality asked us to find when our expression is negative. The sign of our quotient is negative to the left of 6 and to the right of 15 halves. So our solution set, graphed on our number line, looks like this. We've shaded in all the values to the left of 6 and all those to the right of 15 halves. Now notice, the original inequality said less than or equal to. We can put a square bracket around the 15 halves, but we cannot put a square bracket around 6. If we did, then we would include a value which would make the denominator 0, and that's not valid. In interval notation then, our solution is the interval from negative infinity to 6 union the interval from 15 halves to infinity. And again, note we have a bracket around 15 halves and parentheses around everything else. Today we've looked at several different kinds of inequalities. Now, one of the most important things to remember is that when we multiply or divide both sides of an inequality by a negative number, we must change the direction of the inequality sign. We've learned how to use interval notation, and we've also recognized that we need to brush up on our skills for solving quadratic equations and rational equations, as these skills will be used in solving quadratic and rational inequalities. Have a good day.